In this video, we're going to use the two-way table to help us calculate some probabilities. With the two-way table, responses are classified according to two variables. So we'll read the narrative and then look at what the variables are listed in the table. This scenario is about fighting probability of fallow deer bucks, and it's found in Aggressive Behavior, the January-February 2007 edition. Zoologists investigated the likelihood of fallow deer bucks fighting during the mating season. During a 270-hour observation period, the researchers recorded 205 encounters between two bucks. Of these, 167 involved one buck clearly initiating the encounter with the other. In these 167 initiated encounters, the zoologist kept track of whether or not a physical contact fight occurred and whether the initiator ultimately won or lost the encounter. So it's important to know that contact is what's determining whether there is a fight or not a fight. The buck that is driven away by the other is considered the loser. So that is also important. A summary of the 167 initiated encounters is provided in the accompanying table. Suppose we select one of these 167 encounters and note the outcome. So the summary table is given. The different events are initiator wins, or no clear winner, or the initiator loses. Remember, losing is determined by the buck that is driven away. The other two events are a fight occurs or no fight occurs. So you can see there are 5 different events, and if we list those, it will make calculating the probabilities a little easier and more organized for us. So part A is asking, what is the probability that a fight occurs and the initiator wins? Well, to determine this, I'm listing what the events are. So where I've put arrows above, I've written out using the notation for event. So I'm calling event F fight. I'm calling event N no fight. Event W is initiator wins. Event T is no clear winner, because that's what we would consider to be a tie. And finally, event L is the initiator loses. So we have 5 different events to choose from. So we have 5 different events. Now that we have all of the events listed, we'll consider the question again. What is the probability that a fight occurs and the initiator wins? So fight occurs is event F, and the initiator wins is event W. So I'm looking for the probability that fight occurs, that's the probability of F, and the probability that the initiator wins. So P of W represents the probability that the initiator wins. The word "and" tells us we are looking for the intersection of these events. So if we go back to the table, look first for the probability of a fight. So all the numbers dealing with a fight, 26, 23, 15. We are wondering, how does that intersect with the probability of the initiator wins? Initiator wins are the numbers 26 and 80. So you can see where there's some overlapping. Right there at the number 26 is where these two events intersect. So to calculate the probability of the intersection of these events, we're going to use the number 26 and divide that by the total possible. Remember, there were 167 observations. So 126 divided by 167 is what we would be calculating. So we could leave our answer at 26 over 167, or we could use a decimal value to represent the probability. The decimal equivalent is 0.156. So we know that the intersection of these two events is represented where the events are overlapping. Fight and initiator wins both have the value 26, so 26 is the intersection. We then take 26 and divide by the total possible, 167. For part B, the question is, what is the probability that no fight occurs? So we want to find that event on the table, no fight. And if we take the values of 80, added to 12, added to 11, we get the total 103. So 103 out of 167 is our fraction. Once we convert that to a decimal, we get 0.617. For part C, what is the probability that there is no clear winner? So we find on the table where it says no clear winner. So we are taking 23 added to 12 equals 35. So we have 35 out of the total 167. 35 divided by 167 equals 0.210. For part D, the question is, what is the probability that a fight occurs or the initiator loses? So looking at the table, fight occurs involves the numbers 26, 23, and 15. And then we have initiator loses. So initiator loses would be the numbers 15 and 11. And we can see that these two events intersect at the number 15. So we're only including the numbers 26 plus 23 plus 15 plus 11. So I've written that already, 26 plus 23 plus 15 plus 11. And notice that 15, even though it occurs in both events, it's important for us to only include that value one time, because the additive rule, remember, tells us that the probability of the two events is added, but we must subtract any intersection of the events. You can see if I write it out here, probability of F is 26 plus 23 plus 15, and then the probability of L is 15 plus 11. You can see if you've lined it up, 15 repeats, so only count 15 one time in your total. The last question is asking us, are the events no clear winner and initiator loses mutually exclusive? So if events are mutually exclusive, there are no sample points in common, so their intersection is equal to 0. So first let's find those events in the table. No clear winner, 23 and 12 are no clear winner. And then initiator loses would be the numbers. You can clearly see that those events share no values. Nothing is overlapping or intersecting, so they would be mutually exclusive. So our answer is yes. There are no sample points in common, so we do have a mutually exclusive event.